What's up, JDI? What's up, guys on TikTok? Hey, everything's going great, Soul. I got some upgrades on the machine, repaired some things, did a little bit of troubleshooting, and now we're back in business. Greetings from Spain. Much love to Spain. We're back in business, everybody. Mark 4.5. Much love to Canada. What's up, guys? We're on YouTube as well. You want the best quality live stream, it's going to be on the YouTube channel. Guys, I've made some upgrades to the reactor. See these right here? These, contrary to popular belief, are not pieces of my body that will be dangled in your mouth. These are actually keyless remotes to turn on and off this machine from a distance, safely. So, that's amazing. And that's the latest new upgrade I've been working on. You said to use MIG or TIG. I did MIG. Flux core. Sandra, thank you for the $15 early Cash App donation. I appreciate you and your contribution to the project in history. So, guys, we're not wasting time. We're running this reactor today. Low power test run number... What are we at now? Are we at 3? The last one, the thing slightly exploded, right? So... I can't really consider that a success, but, you know, honestly, when you're doing tests, even the biggest failure is a success, because it's better that it explodes now when it's low power, when it's small, than for it to explode when it's way bigger, right? It's always better for that. So, with that being said, I'm like, let's get right to it. Let's get to running this thing. So, let's put in some plastic. That's the first step. And the rest will be pretty simple, because I can just pretty much turn everything on with these keys. So let us move these cameras back to where you can see me loading the plastic. And we'll go ahead and get started with this puppy ASAP. You guys on YouTube can see. Cool. All right, Instagram. Got a few different live streams going on right now. Let's see, can you guys see? Yep. Cool, cool. All right. There you go. And last but not least, Facebook. Here you guys go as well. So we already have some plastic in this reactor, but I just like to load plastic in anyway. Every time. Just so anybody that doesn't, you know, you guys know there's plastic in there for fact. You know, it's just something I do. So I got a bag of shredded plastic here. Thanks to the amazing plastic shredder, you guys have donated bigger donations. We were able to get. Let's go ahead and open up these valves here, so we can go ahead and get these get this plastic in here. You're gonna see the plastic fall down the window. So we'll just put some in. Like I said, there's already plastic in there. I'm doing this mainly so you know for a fact that this thing is running off of plastic. Oh. I gotta be careful. It's windy out here. I'm not trying to blow plastics everywhere. These plastics are they're shredded so fine that they get blown away easily. It's kind of. I'm gonna have to add some type of net to this. Clearly, in the future. Because I do not want to be getting these microplastics blown everywhere. We don't want to do that. That's the last thing we want to do. Okay, so after we add plastic, we have to add in some carbon, which will allow the plastics to absorb microwaves. So I have some carbon. And we take this carbon and we just put it in the same way. We're going to see it fall down. And then we have blades on this machine that spin the plastic while it's on the inside and help mix it and agitate it. There's nothing to see here, but I'm going to turn on the blades forward and reverse just to mix everything together. All right. After it's mixed a little bit, you want to close the valves now. Get this thing nice and airtight again. I gotta clean this sight glass. It clearly got dirty. And let me show you guys, if you remember last time when we were running this thing, we had a small explosion happen. And I actually have a method of preventing that from happening again, other than a pressure release valve. Okay, so let me tell you guys why it exploded last time, okay? I'll tell you why. That's where you start with any solution, right? Okay, you always start with the why. So, I'll tell you. Last time, we ran this machine under vacuum for the first time. Meaning, we had all the air sucked out. It was under negative pressure. Now, I had a vacuum gauge on this thing to let us know when the vacuum was gonna neutralize, because what ends up happening is the plastic breaks down into a vapor in here. It becomes basically natural gas, right? And that natural gas is gonna fill in the lack of space, or it's gonna fill in the vacuum and bring the vacuum gauge to zero, right? It should do that when it works properly. And when that vacuum gauge is zero, you will then know, okay, now it's completely full of natural gas. There's no oxygen, no air gonna be sucked in when you open up the valves. My vacuum gauge broke, so it never did that. So I kept it closed, and it just built up and built up and built up, and then a small explosion happened. Now, I fixed that because I actually have a solution. I do have a pressure relief valve on here, but it's set for too high of a pressure to go off from a small explosion like that, right? What I have done is this right here. This is an old trick. It's called my balls. In your face. This is a yoga ball. And this yoga ball is going to be hooked up to the output of this reactor, to this output valve, right? And what's going to happen is, we're going to plug in the well, the vacuum is already plugged in. We turn on the vacuum, all the air is going to get sucked out of the yoga ball is going to get completely deflated, right? And then, guess what? When the pressure starts to build up, the yoga ball is just going to naturally fill up on its own. I don't have to open a valve or anything. It's just going to start filling up. So you see right now, I mean, we got to suck out some more air. But this thing, my ball is deflated, right? And what's going to happen is my ball is going to fill up full of vapors. And I'm going to put it in your mouth. I'm just playing. But it's going to fill up. We're going to see this ball fill up full of vapors. So it will be visual. It's going to take some time because it's a low power test run. Only 2 magnetrons. But that is how I solve this issue, and that we won't have that type of explosion again. If we have other explosions, they're going to be from other things. So anyways, we're going to go ahead and suck all the air out, and you're actually going to see this thing deflate some more. That's why I have it up here. I'm going to put it on the ground when we actually run it. But look, I got my keyless whip here. We're about to turn on these the vacuum pump wirelessly, baby. Open up that valve. Boom, vacuum pump is on. You're going to see this thing starting to deflate. Even more than it already is. And right now, I have a vacuum gauge on the way. Because my other vacuum gauge broke. But it's not here yet. Amazon didn't deliver it. So I'm kind of basing it off of this. Because you see, when this thing gets deflated like this, we know if this thing is this deflated, that means that this, the air is out of here because this is the last thing. So, I would love a vacuum gauge, and I have one on the way, but it's not here yet. And I wish it was. So, now you can see this thing is flat. I mean, it's no longer my ball. It's actually my plate. Okay? My plate's in your mouth. My plate in your boca. Alright, so now this is about done. We got pretty much almost all the air out. It's not a perfect vacuum. We don't need a perfect vacuum. Alright, so turned off the vacuum pump, closed that valve. It's a solenoid valve, so it's electronic valve too. Alright, this thing is completely empty and sucked to dry. Clearly you guys have sucked me dry here. And now we can turn on the machine itself, okay? Now, before I do that, I can turn it on wirelessly too, okay? But before I turn on this machine, let me move you guys closer so you can see. There's a few visual things that we want to pay attention to. Okay? One of them is the yoga ball. But another thing is, matter of fact, where can I put this yoga ball where you can see it? That's the question. Where could I possibly put this yoga ball? Actually, I think the cameras are at a good spot. As long as everybody can see the pipes, we good. Yeah. Oh, you guys can see. And you can see the yoga ball too, right? It's going to fill up really slow, but it will fill up though. Let's see. I think YouTube needs to come up a little bit. Here we go. All right, yeah. Okay, so everybody's good. You guys can pretty much see everything. I just wanted to make sure everybody could see what's going on before we go ahead and turn this thing on. So what's going to happen is we put plastic in this machine. We mix the plastic with carbon. Since the plastic is mixed with carbon, the carbon is going to get heated up by the microwaves, which will then heat up the plastic and break it down. And since there's no oxygen in here, since this is under a vacuum, the plastic will not catch on fire under the heat. It will instead break down into a vapor. Make sure my connection is still here. My Ethernet, I think it went out. There we go. My bad, guys. My bad for the lag. My Ethernet had got disconnected, but we're back online now. Plastic breaks down into a permanent vapor and also a condensable vapor. That vapor that's condensable ends up going through these condensers here. You see where the water pumps are hooked up. Those condensers turn that vapor back into a liquid. So it ends up becoming the gasoline, diesel, jet fuel, the crude oil. But there's some vapors that never condense. Those vapors that never condense are what we're going to route into this yoga ball here. So when you see this yoga ball fill up, what you're seeing is natural gas from plastic filling up this yoga ball, essentially, right? So if this yoga ball is filling up, that lets us know the reactor is working. And that also lets us know that plastic is being turned into fuel. So, with that being said, we'll go ahead and turn this thing on now. As I say, we always do a prayer before we turn this on. Because you never know when you turn something on you made in your backyard. Is it going to blow up? Is it going to work? Are you going to be safe? You never know until it's already done, right? So let's go ahead and turn this thing on. All you're going to hear is a fan when it's on. That's it. All right. It's on. The machine is on. Now, since we just turned it on, and once again, this is a low power test run, what's going to happen is it's going to take a while to get up to temperature. We're not going to start seeing the yoga ball fill up, or we're not going to start seeing what we want to actually see until this thing gets up to temperature. And the good thing about microwaves is, the reason I use microwaves is because microwaves work very well. Hey, Memory, I just see you bought a badge on the Instagram. Thank you so much, Memory. I appreciate your support on it for the badges on Instagram. Oh, let me see. Oh, I missed up on some Cash Apps. James Goodman, thank you for the $5 donation on Cash App. I appreciate you and your contribution to the project and history. As I was saying, microwaves, they work very quickly. They're very efficient, right? When this thing is actually, you know, at full power, because right now we are at about, well, we have 2 magnetrons. We're gonna have at least 8, but we're gonna have up to 12. So we're under power right now by a lot, very underpowered. But the good thing is this, right? When this thing is operating under the proper power, when we turn it on, it's gonna be instant. All right, instant. You said, could you cook your Hot Pocket in here? You could. It's a microwave. I've built a microwave at home, right here. But since this is very underpowered for the size of this, especially, it takes a while to heat up. Vapors take a while to form, let alone to get in there. So we're gonna have to run this thing for almost 2 hours, probably to just get almost a few drips or drops of fuel. Yeah, it needs to warm. So that's the thing. When you build a big machine, you actually have to put a lot of power into it before it becomes efficient. Because since there's only 2 magnetrons, so little power going in, it takes so long to heat it up. Because microwaves don't heat up the metal, they only heat up the microwave. I mean the plastic, right? But the metal needs to be warm for the vapors to properly, you know, travel and condense like they need to. And that's way easier to do when you have 4 or 5. I noticed in my last reactor, Mark IV, my best reactor up to date before this one, when I had 3 magnetrons operating, that was kind of the minimum. We didn't want to be below 3. 3 was a good number in terms of, you know, the amount to make it work and to have it work well. Right now we're at 2, so we're going to be getting 3 on there pretty soon, within the next 2 days. We're going to get 3 magnetrons on there. And then that will instantly make this work way better. Because what ends up happening is when you have multiple magnetrons coming in, or the microwave emitters, they basically shoot in microwaves, and the microwaves combine with each other. Some of them combine with each other. Some of them destroy each other. Some of them do weird things. Some of them diddy each other, right? But ultimately, what we want them to do is come together and form a gigantic, big black man to touch the plastic, right? That's what we want to happen inside of there. And that's why when we're adding more and more, it gets better and better, right? So, let me actually see. Let me make sure this is in sight for everybody, the yoga ball. I see you guys on TikTok can definitely see the yoga ball. Because I'm talking to you, right? I'm talking to you, but as I'm talking to you, my balls are going to be filling up. And you're going to watch as they slowly fill up as I'm talking to you. But it got to be in the sight though, right? It's got to be in the sight. Or you're not going to know. Okay, yeah, there you go. Okay, so you guys on Instagram can see. What about Facebook? Can you guys on Facebook see? And by the way, TikTok, because you guys on TikTok, you banned me last time talking about my balls. I'm talking about my yoga balls. TikTok. God, you know? Come on, TikTok. TikTok was saying I was talking about SA, right? Acts of SA on people. No, I'm not. No, I'm talking about microwaves diddying plastic, and I'm talking about my yoga balls being filled, right? What's wrong with that? You're the one with the dirty mind, TikTok, because you're thinking I'm talking about something else. I'm talking about my yoga balls being filled and being put into people's mouths. There's nothing wrong with that. There's nothing wrong with that, ever. If somebody wants yoga balls in their mouth, that's okay. But they're thinking I'm talking about something else, okay? That was what I was asking last time, if you were going to run a vac. Oh, if you could tune the magnetrons. Yeah, so that's some advanced stuff, right? To tune the magnetrons to make them work together and kiss properly. I'm not doing all that mess, because I've built reactors before with many magnetrons in. We've had 3 on at once. I think we've had up to 5, but we've operated 3 on at once. And I mean, like, it's worked great, you know? I've seen the power upgrade. So I'm just always checking to make sure nothing's leaking. I like to catch stuff early if something's gonna happen. Check my pressure gauges and my gaskets always. Oh, it's starting to fill up. You guys see that? Look at me touching this. You see me touching that? It wasn't like that before. It didn't have that bounce to it. It got some bounce now. My balls are starting to fill up. All right. You say I'm checking for I'm checking for Diddy. You're funny. You're funny. No, Diddy's checking for me. Plot twist. Because who got the balls here? Clearly me. I tuned in and I was gonna say it sounds odd, but anyway, what's up, dude? How's things going? Hey, things are going great. You know, some people thought when the reactor had that small explosion, it was a weld going off. No weld at all. All the welds are 100% solid. It was a gasket, because when you have the microwaves, the microwave mounts, right? To get microwaves into the machine, you have to have a special type of gasket, because you can't just use anything. If you use anything, microwaves would destroy your gasket and eat it alive, right? They would touch your gasket. They would do things to it, right? Very naughty things. Thank you, dude, for the donations on TikTok. I appreciate you for your contribution to the project. So you have to use a very specific material, but the issue is that very specific material is kind of weak to pressure. It's good for temperature, but under very high, sharp spikes of pressure, it can blow sometimes. Right, so I'm still optimizing that gasket material to make it the best possible, because obviously we're gonna have this thing under pressures at some points, right? That's just inevitable, right? That's about as inevitable as I say I gotta be careful what I say, because the last time I got banned on TikTok for a week from going live. You know, maybe it's the matter of language, right? Timothy, thank you for the stars on Facebook. Well, let me see. I think YouTube chat is behind. You said where you live? I'm in Georgia, United States. Copper is the best gasket material. No, but there's a and here's what I'm telling you. Because when I'm saying gasket, you're thinking like, oh, just this thing around the perimeter of a hole. No, it's not like that. When you have a gasket for microwaves, the gasket has to cover the whole thing. And it has to be something that microwaves can go through. Microwaves cannot go through metal, so I can't just put a metal sheet over there, or else the microwaves won't be able to get into the chamber. It has to be a material that microwaves can go through, but it stops gases from escaping. So it's a very particular material. I've had to study a ton. I've had to literally study some aerospace stuff to find this material that I've been using, but I'm still testing it, right? You said the balls, how long does it take for the balls? You know, it depends on how much power's in the reactor. This ball is starting to fill up. It's growing slow, but I'll show you guys. It's definitely not sucked dry anymore. See that? Look. It's starting to fill up. So what does that mean? Well, since this ball is starting to fill up, and we have this thing under vacuum, that means that actually these vapors, the plastic is being turned into a vapor, and that vapor is going through all the plumbing and making its way here. And that means that we're making fuel from the plastic. Very slowly making fuel from the plastic. That's what all that means. Roland Cody, thank you for the $20 donation on Cash App, Roland Cody. I appreciate your contribution to this project and to history. So you guys see, this reactor's pretty chill, right? Oh yeah, I love Nile Red. I was just watching a video of his the other day, the one where he was making purple gold. But yeah, like, this reactor's chill when it's not exploding. Somebody donated 400 stars on the Facebook. Let me see who did it. Who did it? Was it Diddy? I don't know who donated 400 stars. I see who donated 500. Thank you again for the stars, man. I appreciate your contribution to this project. Thank you, your local memester, for the donations on the TikTok. I appreciate you guys. So yeah, we're making gas and oils. We're making natural gas and crude oil, pretty much. So everybody's always talking about Diddy. I wonder why. Brains Heart Just Say, thank you for the 10 stars on Facebook. It's a keys. All right. I just love to angle things over your mouth and you know, tease you. Thank you for the donations to do it on TikTok. You know, I just love to add to it. We got somebody from Russia on the YouTube. Unfortunately, I do not read Russian, so I don't know what you're saying. But if somebody could translate that, or maybe you could translate what you're saying, I'll be able to, you know, respond. Can you make JA1 with it? Yeah, you can. You can make any fuel with it because it's crude oil, so every fuel of the world is there. Zach, thank you for the $5 donation on the Cash App. I appreciate you, Zach, very much for the contribution to the project. As a matter of fact, yes, it's filling up slow. I'm going to see what the temperature's at. Right now, my temperature gauge is purely in Celsius. You said, can you fill propane tanks? You can, and I actually have before. You can go back on my YouTube channel and see. We make this gas, fill up my yoga balls with it, and compress the gas out of the yoga balls to modify propane tanks. Yeah, it's still heating up. It's gonna take a while. That's the thing about these low power test runs that piss me off, because the whole reason I started. Let me tell you guys a story. How did I even get to the point where I'm doing microwave pyrolysis, right? Pyrolysis with microwaves. Thank you for the 100 stars on the Facebook. Brett Wax. You gave me some teeth. I didn't know Facebook even had those emoji donations like TikTok. Let me tell you guys a story. Thank you for the $100 donation, Brett Wax, for the 100 star donation on the Facebook. I appreciate you. So here's the story, guys. I built regular reactors, okay? I built some regular traditional pyrolysis reactors. Now, what are traditional pyrolysis reactors? Traditional pyrolysis reactors are reactors that operate off of flames. So like you're burning natural gas under the reactor, have the plastic in the steel container, heat it up. Thank you for the 100 stars, Brett Wax, on the Facebook again. I appreciate you. And I had done that for a few months, right? The traditional pyrolysis reactors. And I mean, it works. It'll turn plastic into fuel, just like this does. But it takes so long. It's so slow. It's so inefficient. And I was like, so how long is a while? Well, for reference, it really wouldn't even start making vapors out of the plastic into almost 30 minutes of being on, right? Compared to microwaves, they start instantly. And this is doing it now. It's just that since we vacuumed out everything, the vapors need to fill in the whole chamber. It's a big chamber, very low power. It's going to take a while, right? But I've built small reactors before. Microwaves instantly turn plastic into vapor. Compared to, you know, vapor's the first start, right? Once the vapors form, the vapors need to heat up the pipes. The pipes then need to go to the condenser. The vapors then can be condensed, right? So for it to take 30 minutes just for you to get vapors, you're waiting a while, right? For example, a very small run on my traditional pyrolysis reactor that run off of a flame. Thank you, Brett Wax, for the 500 stars on Facebook. Thank you very much, Dakota Barnett, for the 30 stars on Facebook. So, for example, a very small run. Oh, we got a badge on the Instagram here. Thank you, Chef. Chef, for the badge on Instagram. I appreciate you, Chef. Zach, thank you for the badge on Instagram. I appreciate you, Zach. I appreciate all you for the donation. You guys did not just say I'm Diddy with dreads. I know I did not just read that comment on Instagram. Y'all did not just say that. Yo, y'all crazy. I know y'all did not just say that I'm Diddy with dreads. Hey, come to my party. I'm throwing a house party, all right? Come on, guys. Come to Diddy's party. Dreadhead Diddy's party. Come on. Translated, do you use argon gas? No, I do not use argon gas. Tell him I use vacuum now. I suck it out. Yo, you said you're good? No, come on, come to my party. Seriously. We'll have lots of fun. Listen, we'll have a secret back room too you can come to. And I'll make sure that you're very well taken care of in the industry after the fact, okay? Just come to the room with me, and you'll have all the riches of the world afterwards, all right? Come on. I'll just stick my dreads down your throat. That'll be all I'll do. Brian, thank you for the badge on Instagram. I appreciate you. So what are we doing now? What was I saying? Traditional pyrolysis reactor. All right? So traditional pyrolysis reactor, when I would run a small run, right? Like literally putting in a few bags of plastic. Or you could put in any amount pretty much. It takes like minimum like 8-10 hours pretty much. Every time. Thank you for the 10 stars on Facebook. John Shannon. Take a long time every time, no matter how you put it. So I was doing that for a while and I was like, this is just not gonna work, right? This is just not efficient. I gotta do something better. And then I was just thinking about ways to heat things up, and I looked at my microwave and I'm like, well, a microwave cooks a hot pocket way quicker than an oven does, right? In fact, it's the most efficient form of cooking in the whole house because microwaves cook from the inside out versus everything else cooks from the outside in. So you're not wasting energy heating up the metal container or the air. You're heating up exactly what you want to heat up. John Shannon, thank you for the 10 stars on Facebook. Brett Moore, thank you for the 30 stars on Facebook. Have you tried using sun harnessed heat? That's a great thing too. The issue with using sun heat is look at the reactor. It's solid steel. How are you going to get sunlight in there? You know? If you can't make it out of glass. You can't do it. You can't make it out of glass. It's not going to work on a scalable level. You can't scale it up if you build this thing out of glass. So, microwaves heat with volumetric heating. They heat from the inside out. That's always more efficient than having to heat up the air or heat up the metal to heat up what you actually want to be cooked. Always. So that's why we use microwaves. And I started to experiment with microwaves. Used my first microwave pyrolysis reactor. And noticed how quick it was, how much more efficient it was. And that's why I'm like, okay, great. But here's the thing. I built my first microwave pyrolysis reactor. It was literally 1/10 of the size of this. And I noticed as I built bigger and bigger reactors, when you start to build them bigger and bigger, the microwaves only become efficient and are only worth it when you have enough on them, on the machine. You need a microwave at every section of this machine because it's so big. And we need the vapors to really start heating up and the metal to start heating up. So, with that being said, that's why right now everything's taking a long time when we just have 2 microwaves going here. Matter of fact, I'm gonna check everything. 1 second. Yeah, we got some heat there. I got a temperature probe. It's at 47°C. That's the body temperature. So once again, going back to what I was saying before, microwaves heat from the inside out. So if the body temperature is 47°C or almost 100 degrees Fahrenheit, that means the inside might be 200, right? For example. Now, Amazon just delivered my digital vacuum and pressure gauge. I'm going to go get it, and we're going to put it together here, because we got to wait anyway, right, on my balls to fill up. So I'm gonna go get it. Give me 1 second. I'll be back. All right, I got it. It's right here. You know, once again, I appreciate everybody who donates, because literally, it's your donations that let us get things like this that help out. This is a safety thing. You want to be able to know what the pressure is. This is a vacuum and a positive pressure gauge. So this alone will let us know the vacuum that we pull on this, as well as if it's starting to raise in pressure, and it's digital. And that's good because that means I don't have to be all up on it, you know what I'm saying? Like, I don't have to be near this reactor to see it. I'm sure the HVAC guys in here are familiar with this. You guys use some similar things. Somebody said this looks too expensive to be fake. Yeah, look, it'd be crazy if this was fake, because even beyond the money, how much all this cost, when you think about the amount of time, you know, because I have it on camera, I was live streaming, just how long I'd be sitting here welding this thing together. Like, good Lord, the amount of time, and then on top of that, the risk. Like, I'm scared every time I turn this thing on, even with the remotes. I'm scared, because it's already blown up in my face, live. That's already happened. And then on top of that, you can be electrocuted. I mean, there's just too many risks. So I'd be doing a disservice to myself if this thing was fake. With just how much effort I've put in and all the risks that entail or come with this, it'd be a disservice to my damn self if this thing was fake. Now, of course, on top of that, you just go on the YouTube channel, you can see it all. See absolute certainty. Or look, you could just be in the live stream. See, we got some vapors in here. These vapors are forming mad slow. I'm not even gonna lie. I don't know what's going on with that. They're forming mad slow. Alright, I'm gonna put this thing together here. Yeah, we gotta wait anyway, right? This thing is sure taking its time today. But I just checked, everything is on. You know, the thing is, here's the thing, I'm not spinning the blades either. Because right now, we're just trying to get the machine to work. And work safely and consistently. Spinning the blades is a whole nother demon. Thank you for the $10 donation, Nickery D. Paul on the YouTube. He said, keep it up. Gotta run. Sadly, grandmother's funeral. Oh man, rest in peace to your grandma. I hate to hear that, but Thank you so much for stopping by in the live stream. And blessings and peace upon you, truly, man. Thank you again for the $10 super chat on YouTube. So, as I was saying, spinning the blades increases the pressure even more. So, you know, when it comes to the blades, we want to do that once we can confirm without the blades that we're safe and it's not going to explode like it did last time, okay? You know, you just slowly build up. I did the same thing with Mark IV. In fact, if you go on my YouTube channel, you'll see I have a ton of videos being like pressure testing Mark IV plastic to fuel reactor. Because you know, we do this. This is what we do. We make sure we're not going to blow ourselves up for the sake of safety. So you see this right here? I got this thing nippled up on there. TikTok don't ban me because it is a nipple, okay? And now what I can do is I can hook up my my leads to this, right? From here, and then I will be able to hold this thing in my hand right here and know what the vacuum or the pressure is in there. I don't have to guess. Giovanni, good to see you again, Giovanni. Hey guys, everybody that wants to know, Giovanni is building a microwave pyrolysis reactor himself. So, W to Giovanni, embarking on this journey. So this will let us know if this thing is still under vacuum. It will let us know if it's under pressure. So it's a good thing to have, for sure. Let me go ahead and hook this in. Right now, actually. And it will let me know from a distance. That's the amount, the most important thing, right? Because the amount of safety that comes from a distance. You guys remember, when this thing blew up, the explosion happened on the other side of me. Now, I've designed this like that on purpose, right? But that's very important because, you know, I don't want to be anywhere near it if it explodes, right? I don't want to have to get next to this thing to know the pressure. All right, the body temperature, I just checked it. The body temperature is at, it's at 50 C right now. So it's gone up by 3 degrees Celsius. Once again, that's the body temperature. That's not the inside. Do not misconstrue the two. They're different. All right, so the body temperature has gone up, which does mean microwaves are on. Plastic is breaking down. Just going slow because, I mean, it can only go so fast. Can only go so fast when you only have 2 magnetrons in a big space, right? That's like the equivalent of like, let me break it down for you. I'm gonna give you guys an analogy in a second. 1 second. I'm gonna give you an analogy for that. Right now, according to this, the reactor is still under vacuum. It's at negative 0.003 psi, so under almost no vacuum, but it's still under a vacuum, according to this. Now, this is my first time using this. Oh, here we go. Now, this is the actual vacuum meter for the HG. It's at negative 007 HG. So we still have a vacuum in here, which is a little bit weird because it's been running for some time. Why is it still under vacuum? I don't know, but at least I don't have to guess because we got this thing right here to let me know. You see what I'm saying? And look at me. I'm from a distance. I'm safe. So anyways, I was speaking of an analogy, right? Because I was saying the reason why right now this thing is working the way it is Not really working how I want it to. Going really slow is because we have 2 microwaves, right? In taking up this huge, trying to heat up this huge body of space. So that's the equivalent, right? Of let's say, an elephant. No, a hippopotamus, right? A hippopotamus, right? You go up to a hippopotamus, and then it opens up its big mouth, and you try to put your small balls in its mouth. Like, it's gonna be like, what? You're not even a quarter of it, right? You're not even a fraction. Compared to me, if I go to put my balls in the hippopotamus' mouth, then it might, it might have its jaws going through a little stretch a little bit, But that's the analogy, right? Just to break it down for you. So that's what's going on here. 2 magnetrons, huge bit of space. We're not gonna get where we need to get until we get at least, I reckon, 5, 6 on here. That's when we're gonna really start getting this thing how we want it, right? I like this thing here. I like it. The only issue is, it may not last long, and I'll tell you why it won't last long. In order for this to work, no, actually that's not true. I can hook it up anywhere. I was about to say, right now this thing is hooked up to the raw import side of this. So the raw pyrolysis gas, which is corrosive and all type of stuff, is going right into this thing. But I can actually hook it up after the filters coming off of this. Just put a little T on this thing, on the output thing, and put it there, because the pressure is going to be the same everywhere in the reactor, right? So how did it just go up in vacuum? It says now it's in 0.004 vacuum. It was in 0.003 vacuum. Mr. Smith sent $10. He said, happy Friday, just want to support the movement. Thank you, Mr. Smith, for the $10 cash app. I appreciate you. Thank you, Late, for the badge on the Instagram. I appreciate you guys for your contributions and your help out, your support for the project. Thank you for the 100 stars on Facebook. Brett Wax, you've been donating and all. I really appreciate you. He said, the elephant. Let's talk about the hippopotamus. That's what I'm saying. We're talking about the hippopotamus. I can already see a little bit of condensation going on in these pipes. So I definitely got to hook it up to that end, or else this is going to be destroyed quickly. But this is actually cool though, because this tells me the vapor temperature as well. The vapor temperature is at 30 C, or about, give or take, 85 degrees Fahrenheit. So that lets us know this thing is not hot. This thing is very cold right now, and that's why we're still waiting. Said it's keyless. Yeah, all my whips is keyless. Look, hold up. All my whips is keyless. We can turn this thing on and off, and I got the vacuum and the solenoid valves all hooked up. And look, this is just like a fraction. Like, this thing is going to be a dense keychain, because I just have, for example, 2 transformers on here to turn on the microwaves. We're going to have 12. That's 12 of these. You can't even imagine 12 of me in your mouth. You couldn't even do that. It's too big that your brain couldn't even imagine it. Imagine it actually happening, right? Imagine that actually happening. Taylor, thank you for the 99 stars on the Facebook. Thank you for the 50 stars, Brett Wax. I appreciate you guys. All right, so apparently it's still under vacuum. I don't know. That doesn't make any sense to me. What I might do, I'm about to do something that could be dangerous. It could result in an explosion. I'm letting you know right now. What I'm about to do could result in a small explosion, all right? So everybody pray for me right now. I'm about to unplug this for a second, because I want to see if this thing is really still under vacuum, or if this thing is just off, because I've never used it before. It may not be calibrated. What? I don't even know what this thing is saying. I'm going to unplug this thing and see if it sucks in air. If it sucks in air, I'm going to plug it back in immediately, because that means it's still under vacuum. But it shouldn't suck in air, because we've been doing this. We've been running this for like 30 minutes now. It should be making enough vapors to where there's no vacuum anymore. But according to this, there's a very small vacuum still in there. The yoga ball is not really... I mean, it's not... The yoga ball is not sucked dry, but it's still, pretty small. It should be better. Watching from Nova Scotia, Canada. Hey, much love to Canada. Thank you very much for the 99 stars, George. We're gonna do it, guys. It'll be all right. Like I said, I'll be quick with it. I can always close this valve too, as an emergency. Oh, it's not sucking in air. Okay, I'm confused. Now I'm confused. Hold up. Hey, guess what? We unpacked this Amazon box. Guess what we're gonna do with this plastic? Guess what we're gonna do with it? We are gonna utilize this plastic as fuel. So that way I can run my generators to run my Diddy party. All right? And you're gonna be there. Yeah, oh, this thing is bugging because it's still going up. It says we're at 0.005 of a vacuum. There's no way we're at, I think it's the moisture from the vapors that are bugging this thing out. Because there's no way the vacuum is going up. That's not possible. Yeah, my vacuum pump isn't on, but if it was on, it certainly wouldn't be 0.005. It'd be like 0.5. So, clearly, this thing is bugging, clearly. I don't know what's up with that. But according to this thing is still under that. See, and this is the issue. This is why I had the analog pressure gauges, the analog vacuum gauges, because those don't lie. But the issue is, oh my dang, all the analog gauges I get destroyed when I have small explosions, and it's annoying when they get destroyed. All right, so yeah, clearly this thing is tripping or something, because there's not a vacuum. It's not sucking in air. But I don't. Interesting. I don't see vapors coming off. I do not see vapors escaping. There should be vapors escaping the chamber. I'm gonna do a test. 1 second. I'm gonna do something. Okay, I turned it off just for safety, but I'm gonna figure out what's going on real quick. I'm just making sure the microwaves are on and stuff. In fact, that's the next thing. One of the next things I'm gonna get. I'm gonna get a microwave meter so I can make sure I can know for a fact microwaves are on without having to touch anything. But I have them off just for safety. I'm trying to figure out if it's just a matter of I'm not seeing vapors, or perhaps it really is just going that slow. All right, we're good. I was just making sure that both of the magnetrons were working. Because one of them was sounding a little bit weird. So just had to make sure. But I never do that with it on. Never. You said like ice to water? Yeah, that's very similar to what we're doing here. Just like how water has the different phases, so does plastic, so does crude oil. And plastic is a solid form of crude oil, so we're just doing the same thing. Turning the plastic, which is solid, breaking it apart into a vapor, and then condensing that vapor back into a liquid. You said we should buy him a bomb suit? Shoot, yeah, honestly, it's scary. Hey, you know what? Justin Smith on TikTok. It's actually not very far from moonshine, honestly. The process, I could make moonshine with this machine if I wanted to, right? Thank you very much for the donation, Buzzman, on the TikTok. Because, in moonshine, it's the process of distillation. And distillation is actually the same process that they use in crude oil refineries. To take crude oil and to refine it into gasoline, diesel, jet fuel. I already told you, we're pretty much unrefining the plastic back into liquid crude oil. You said fuel shine? I like that. Yeah, I guess so, fuel shine. I think I had this thing in the wrong setting. I had it on the difference. So I think that's why it was giving me negative numbers. It didn't make sense. But I'm still, you know, I never used this thing before. I'm still trying to figure it out myself. I just got it today. It's a manometer. A manometer. Don't tell Diddy about that. Don't tell Diddy I got a manometer in my backyard. He'll be in here in a split second from the Bahamas. He'll fly in on his Gulfstream today, right now. If you tell him I have a manometer back here. So I should get a clamp meter for the electrical input. Yeah, so here's the thing, guys. Actually, you guys can help me, right? Because this thing is gonna run off of generators, right? But we're gonna have so many magnetrons, it's gonna run off of 2 generators. And so with that being said, there's gonna be maybe 3 electrical ports powering this machine. How can I possibly get a meter to detect the power off of 3 electrical ports at once, right? Because I've been thinking about that, and I'm like, well, how am I gonna do that? My last machine, it operated off of just 1 port, 1 50 amp circuit, so I had a 50 amp electrical meter going to the machine from that. But this is going to be different because this is going to be like 2 or 3 different power sources to power this. Thank you for the $20 super chat on YouTube from Real Nagas. Hey, young genius, I left you a message on your website about investing and being able to scale your machine. Please look for the email message from Real Naga. All right, man, thank you very much. And I will take a look at that. I appreciate the $20 contribution to the project in history. I appreciate you very much, Real Naga. And we'll be looking out for your email. Thank you again. So how old are you and how old were you when you started? I'm 20. I started when I was just at the end of 17. Hey, how you been, Giovanni? How's your reactor been coming along? I haven't taken a look at your update videos yet. I'll be doing that today. Thank you for the badge, DJ Brown on the Instagram. I appreciate you. I love this project. I want to help you in any way. Can you please check DMs? The best way if you want to get in touch with me is emails. You said I need a commercial power box. But here's my issue, right? I thought about that too. The issue is Can a commercial power box accept many different inputs and funnel it into one output? That's the issue. I'm gonna have like 2 or 3 50-amp circuits that I want to funnel into one wire, you could say, one giant cable, and that cable is split between 12 magnetrons. But is that possible? Right? I've never heard of that before. I mean, obviously, can be done, but I just been thinking about like how I can do that. So I have half a hydro collider in my backyard. Maybe so. Maybe it's not far from it. You can get units that monitor multiple inputs. I think they provide a sum total too. I'll send you a link if I see one. Thank you so much, Nick. Yeah, send me an email of a link, because I've been really scratching my head about that, because it's very important. It's extremely important to me that we will get the proper science on this, get the proper numbers and things in terms of energy consumption and all that. And I want it to be accurate. So I want to be able to have the meters on everything. The shredder, the air compressor, the motor to turn the blades, the water pump, like every single thing, every single magnetron, the relays, every single thing. I want it to be very scientific, but we have to have, you know, since this machine is the most sophisticated and most advanced one I've had yet, we gotta have, you know, in return, the most sophisticated and advanced power monitoring systems that I've had yet. Essentially a smart meter, right? Because this thing is gonna consume about as much power as a house consumes in a day. So, kind of pretty much a smart meter, right? Like I said, the issue is always multiple power inputs being funneled into one output that we can, you know, actually monitor. So I don't know what's going on with this machine. I mean, I checked everything. Magnetrons are running, vapors are forming, not under vacuum. But it's really taking, like, this thing, I would estimate it should have been full a while ago now. Not full, but, you know, like, we're just trying to come up together. So there's obviously something else going on with the electrical system on this machine right now. Something I don't even know. Well, let me see what you said, Giovanni, about how your machine is. Oh, maybe you didn't respond yet. Is the valve? No, the valve is open. That's why I'm kind of confused too, and it's scary because you know, right now this thing is full of flammable vapors. There are no leaks. No, I did a vacuum and a pressure test before I started it. So no, we don't have any leaks. I don't know what's going on, and honestly, this is the worst time to be trying to troubleshoot, because I have a hot reactor full of flammable vapors right now. And I'm not going to be the one to figure out if something extremely off is going on. But, oh, and on top of that, the reactor is under heat. It's at 51°C body temperature. So microwaves are on. Plastic is being... See, here's probably what's happening. I'll tell you guys what's probably happening. And it's something I don't want to do right now, actually. I'll tell you what's happening. More than likely. The plastic in there needs to be turned. But let me tell you guys the issue. In the past, when I turn the blades, that's when it blows up. Because the blades, when they spin, those pockets of gases trapped in the plastic, they get released. And then it all shoots out at once. Too much pressure. Maybe I'm gonna turn the microwaves off, then spin the blades. Okay, we're gonna see if that does it. Because when I have spun the blades with the microwaves on, that's when we had our explosions. So let's do that. Let's turn the microwaves off. I wonder if I can do it from here, actually. Let's see. Turn them off. Let's see if that works. Oh, no, I can't do it from here. I'm too far away. We're gonna... You said drop to 1 magnetron when using the blades. I want to turn them completely off right now. Because I'm still, like I said, I'm still working on my gaskets to make them better and pressure proof. But I don't feel like having an explosion right now. So I'm going to go turn them completely off. We're going to wait a second, then spin the blades. Yeah, I'm gonna wait. I'm gonna wait just a little bit before I spin these blades. What the heck? I unplugged this, and it's sucking in air. I tell you, okay, we definitely gotta spin the blades. Let me tell you guys what's happening. I loaded in plastic. It's not mixed with the carbon good enough. So the plastic's not really breaking down like it needs to. So we have to spin the blades to mix it, agitate it better. When this machine is actually running, the blades will always be spinning. Right? They will always be spinning. So this one will be an issue. Like, we're doing test runs, just trying to make it safe. So I'm going to put on my safety equipment. Okay? Before we spin these blades, because like I said, that's one that's exploded every time before me. It shouldn't explode because the microwaves are not on, but I'm not taking any chances. All right, we're gonna spin them. Okay, so it was, I mean, I figured nothing was going to happen since the power's off. You know, there's no extra vapors being formed. But since I spun the blades, plastic is mixed better. I'll go ahead and turn it back on. I'm going to keep all my stuff on just in case if it explodes then. But we should be good. Should be fine. And then now we should be back in business. We should actually have to start forming now. Now that it's been mixed together. And my thermometer fell off, but right now, the body temperature is at 77 degrees Celsius. So, we're approaching the body temperature being the boiling point of water, or 212 Fahrenheit, which will mean that the body temperature is over 200 degrees, which means the inside might be 300 or 400 degrees Fahrenheit. Yeah, I'm always like this when I built these reactors. You can actually go on my YouTube channel and see when I built Mark IV, I was the same way. Like, when I'm first building the reactors and still figuring it out myself, I'm so frantic with everything I do. I do like the most, I take the longest route possible. Because, you know, it's scary. I'm telling you right now. You get PTSD when something explodes so close to you. You know? And then on top of that, like, you made it yourself, so it's like, you know, sometimes you're like, I don't know, like, maybe I didn't do a good enough job sealing it, right? Or maybe I do have a small leak in a weld or something, you know? You have that, so, you know, I'm very careful with it. That's how I'm still alive now, to be honest with you. Because I have had the explosions and stuff, but... So how long does it take until it's done? Well, this reactor, when it's operating properly, is going to operate continuously. And that means that it's going to operate like you load it in plastic while it's running. So it really, there's no like time when it's done, right? Is it broken? No, it's not broken. It's fine. I'm just taking the precautions to make sure that it's working properly without shocking myself or causing an explosion. All your reactors are awesome, but this big one is coolest. Thank you. I agree. This is my favorite one, even just by how it looks. Like, this one looks so professional. You know, Mark IV looks good in its prime, but this one is great. And I'm always, like, checking to see if I have any leaks. OSHA's joined the chat. Yeah, OSHA would freak out. Any safety inspector would freak out just by seeing my my electrical setup. Feel like I hear something. Wait a minute. Is that a leak? I hear something. It's just the fan. You see what I'm saying? That's what I'm saying. I'll be paranoid. I'm paranoid at every moment something's about to blow up. It's not a leak, guys. We're fine. I get paranoid. I'm telling you. Okay, it's just the fan. The same fan that's been blowing this whole time. I just heard a different pitch of it when I was sitting right here. And I'm like, wait a minute. Is that a leak? No, we're good. The good thing about a leak on this is not only will you hear it, but you're gonna smell it too. It smells like a barbecue. So, I don't smell anything. And the vapors that come out are cloudy. They're not clear. So you will see it, you will smell it, you will hear it. And if it explodes, you're gonna feel it. Hey, you guys remember when this reactor exploded, the whole reactor shook a little bit. That was a small explosion too, you know? Yeah, definitely gonna have safety controls. You guys are about to see, like, you know, this was just the start. When we get this thing, you know, as we start to flush it out, get all the magnetrons on, I'm gonna have crazy safety controls. There's gonna be crazy stuff to make sure, and there's gonna be so many like different breakers and things to make sure, like, if a fire starts, it'll turn off on its own. Like, there's gonna be a lot of safety stuff because I'm trying to prevent what happened to me last time, the electrical fire, from happening this time. Ironically, my last machine did not explode. It was an electrical fire that was the weak point. We're gonna do a lot to fix that this time. Heck, I might even put an automatic fire extinguisher on this thing. A fire starts, it just shoots it. Like what Tony Stark made when he was trying to make Jarvis. He had that little robot that just shot a fire extinguisher at things. Let's see. Do you have any updates? I'm gonna check the temperature. Oh, the temperature, the body temperature is at 89 degrees Celsius. Almost 100 degrees C, or 200 degrees Fahrenheit. The temperature of boiling water, 212. That means the inside is probably 300, 400, 500 possibly. Eventually we're going to have an internal temperature probe as well. You said my guy Jarvis around, it was Mark II. Oh, okay, see. Yeah. Do you process the plastic before you put it in? We shred it, and that's about it. We shred the plastic, and once it's shredded, we mix it with carbon, goes in, just like that. You have a Telegram group? I don't. Should I make a Telegram group, guys? What's up, Zai myself? Julian, what pyrolysis products do halogenated polymers like PVC produce? From what I've seen, it tends to be phosgene or hydrochlorine gas. Maybe use calcium carbonate to neutralize those products. Yes. So if you put something in there with chlorine, you're going to get chlorine gas. You got to use something to neutralize it, like calcium bicarbonate, or I was using calcium oxide, which is lime, to form calcium chlorates. But I never used PVC in here though, because I don't have the tools to truly know if I'm getting rid of the chlorine. And I'm not allowed to have chlorine in my gas as I burn it, right? So I'm just saying, if you're gonna put things in there, you gotta know what you're putting in there for your own safety and for the emission standpoint as well. But most other plastics, all the big plastics that end up in the ocean and stuff, they're fine. No, they don't make these, they're not halogenated. You said Bill Nye the Science Guy, the dreadhead version? Funny. People were, I can't believe you guys said I'm dreadhead Diddy. I can't believe that mess. Where did you learn all that? I've learned all this online, but then it started to get to a point where it was 100% self-taught. Like, I'm talking about, I'm just learning these things as I go, because microwave pyrolysis has not been something done in the backyard scale before. So when I started to build these, I started to just learn as I went, observations, you know, doing it, you know. It's kind of the best way to learn, right? Let's see if it's still under vacuum. I hope not. It's not. We got vapors coming out, finally. Finally, we got vapors coming out. Goodness gracious. You never know when you do this stuff. And my temperature probe keeps falling off because I duct taped it underneath. And now it's too hot. The duct tape keeps melting away. It's hot! Ouch! Goodness! That's definitely like 200 degrees to the body. I almost burned myself holding my hand there. This is the hottest we've got it. So I'm surprised that we don't have more vapors, but I know why. We need to spin the blades. I ain't spinning the blades with it on because I'm not about to blow myself up. Okay? We're getting to that point. We're doing the slow tests. Okay? Eventually, guys, what we're going to do is we're going to just have one magnetron on and spin the blades to see what happens. Yeah, we're going to have a holder for the temp probe for sure. I just was using a piece of duct tape. I was just just trying to get it or something. I just put it on there this morning. Wasn't trying to do anything crazy with it. Just trying to get it on there. Comparing to lithium, do you believe this version of fuel is more safe? That's a great question. Turning plastic into fuel versus electric cars, lithium mining and stuff. Is it better? Yes, it is. And of course, I'm biased, but I can break down why it's way better. Because guess what the electric cars are made of? Plastic. Guess what the batteries that the lithium is in is made of? Plastic. So, first of all, going all electric is not solving that issue of plastic at all. It's only making more. And we already know all the emissions and all the slavery and all the nonsense that comes to getting lithium. We already know about all that. Okay? But then your electric car is still running off of natural gas, ultimately from a natural gas plant to make that electricity. Because we're so far from every form of electricity being renewable, it probably won't happen in the next half a century. Like, we're so far from that, seriously. Maybe not half a century, but it's going to be a while. So anyways, the truth of the matter is, there's some things that just can't be electric. Everything has its place. You need engines for some things, you need motors for others, but, I've yet to see an electric dump truck, an electric locomotive, an electric plane, an electric rocket ship. I've yet to see an electric, look, truth of the matter is, we don't need to be replacing any type of technology, especially an engine. Have you guys seen an engine? Have you ever truly, I'm telling you, just looked at an engine? The amount of engineering. That an engine is amazing. Okay? It's like a heart. You know what I'm saying? Like, it's crazy, the engineering. And so for us to just be like, let's just completely kick away this technology. No, let's not do that. Engines are amazing technology, so are motors. We can keep them both, okay? We can keep them both, but I do truly believe that turning plastics into fuel and then putting that fuel in your vehicle is better for the whole environment than the current way that we have with electric cars, because we don't have a way to truly recycle lithium. We don't have a way to recycle the plastic from the electric cars by the way we do it, and we don't have a way to get lithium without enslaving people and then destroying the environment even more and destroying ecosystems, right? And polluting even worse than just CO2. The amount of pollution from lithium, to me, completely offsets CO2. And the guy came in here the other day and it was like, do you believe that the CO2 global warming stuff is the same as environmental conservationism? And I say no. Because how are you conserving the environment at all if you're destroying complete ecosystems and enslaving humans to get lithium just to have less CO2? Doesn't make it, what? Man, there's no conservation behind that at all. It's just a number and a metric at that point. How low can we get the CO2? It's not go hand in hand, clearly. Right? It's two different things. CO2, this whole CO2 thing has become very political and it's become very much money-based too. Carbon credits. Tesla made all their money from carbon credits in the beginning. They didn't even make money from selling cars. No profit from cars, purely from carbon credits. Purely from carbon credits. It's money. They don't even do it for the environment anymore. They just do it for the money. But this is for the environment. That's why I started it. So I can get rid of my own plastic waste. Let alone the ocean plastic waste. This is true conservationism, playing into the natural cycles of nature, Mother Nature. We're recycling things. There's no such thing as waste in nature. Alright, so for us to throw away plastic, something that took so much energy to make, and something that has so much energy within it, is stupid. Because go in nature, and you won't see a single leaf from a tree that sheds in the fall time that is wasted in nature. It goes in the ground, it breaks down on the ground, and feeds that same tree next year. I am back, Hurley. TikTok banned me because I was talking too much about, my analogies had gone too deep. I'll say it like that, okay? They don't like me all the time. I'm gonna check again to see these vapors. Yeah, there are vapors, but it's such a small amount. That's the issue. It's such a small amount of vapors. There's clearly something wrong with the machine right now. And I think, I'll tell you guys what I think it is. I think only one magnetron is on. I think the other one is not on. I think it's broken. I can't tell right now on live stream. I gotta do some further tests to know, but I don't think it's working. Because something is really off, like with two magnetrons in here, we should have way more vapors coming out. And we don't have any leaks either. So it's definitely something wrong, but you know, this is a good little stress test on the machine nonetheless. I mean, but the weird thing is the machine is hotter than it's ever been before, so clearly the magnetrons are on. Vapors are forming. It's just really slow. Just weird. I don't know what's up with that. Because if both of the magnetrons were not on, there's no way it would get as hot as it is right now. There's just not, that's not possible. Could it be from the pressure incident? No, I've completely repaired it from the last pressure release we've had. I'm gonna see if these vapors are flammable, actually. At this point, I would think they would be, but they might not be because of how weird everything is acting. In fact, it's too windy, actually. I can't even see them. I can't even see the vapors. Yeah, we clearly have some vapors in here, but it's such a small amount. It should be way fuller than this. Let me see if any oils formed. Perhaps all the vapors are condensing, right? Maybe. Let's see. Let's see if we have any oils at all. Nope, no oils there. I wish I could just see the inside of the machine. I wish it was like glass so I could just see. Because there's something weird. It's getting up to temperature, but clearly I don't think plastic is being broken down. There might not be enough carbon in there, or maybe the plastic that's in there is broken down, or maybe the plastic that's in there got moved too far down, so where the microwaves are not in range anymore. Because we only have them in the beginning. But something is definitely going on here that is it's not operating as it should be. Even for a test run, it should not be this slow. And I like to move very carefully, because it's in these moments where you're kind of frustrated, like, why is it not working? Let's do something stupid and blow yourself up, right? So I'm trying to figure out what it could be. Interesting. I mean, the good thing is this, right? The good thing is, even though it's operating weird, at least it's not something catastrophic or dangerous, like an explosion or a fire or electrical. So, it always could be worse. But it is just weird, though, because it was operating better than this with one magnetron. I'm about to look on the inside of it. I'm gonna unscrew this pipe, and what's gonna happen is the vapors that are in here are actually some of them will be released. So I gotta put my respirator on. So the good thing is this thing is kind of under slight positive pressure, so it's not gonna be sucking in air when I do this. So it won't be dangerous, but there will be some vapors released. This is kind of the closest thing I can get to actually looking at the inside of it to see like what's up. Like, do we have vapors in there or what? I don't know if you guys saw when I opened it, but there are a ton of vapors on the inside of this. You said I sent you 20 bucks. Oh, let me check. I appreciate it. I really do. Let me check. Make sure I didn't miss it. It hasn't come through yet. Sometimes it takes time to load in, but I appreciate the 20 bucks. What's your name? Where'd you go? I missed you. I lost you. Oops. I appreciate the $20, so truly. Oh, Q off one. I appreciate the $20 donation. Q off one. I very much. Okay, so yeah, there's a ton of vapors on the inside of it. A ton. But those vapors are not migrating how we want them to. And the biggest reason why is just because of a lack of heat. Right? That's it. They're not excited enough because it's not hot enough. The volume is so big. You know, it's weird how we've had the vapors go properly before and not now, but there are a lot in there. And, you know, clearly over time eventually. But actually, let me tell you guys something. Since this reactor is so cold, we're getting so much oil condensing on the inside of this. Like, so much. I promise you, if I were to open this, which I won't do, there's going to be a ton of oils just at the belly of this. And that will continue to be the case until we have magnetrons everywhere. So can I fix... You said, can you fix my parents' marriage? No, but I could turn it into fuel. Should we see vapors through the glass? You'll see it get foggy. Like right now it's foggy. But I gotta do some diagnostics. Yeah, there's definitely a bunch of oil in there for sure. So, I mean, it's looking good, right? You know, we're spinning the blades and they're fine. It's not exploding, but we still need to spin the blades while it's on, which is scary. There's a lot of vapors in there right now. I don't know, guys. Should we do it? Should we turn one magnetron on and spin the blades? Or maybe we should spin the blade, like have the blades just spinning and then turn it on. Martin, thank you for the $5 on Cash App. Right? Because if they're constantly spinning, it'll be less of a shock versus spinning all of a sudden. Truly, once again, thank you so much, Martin, for the $5 donation on the Cash App. I appreciate your contribution to the project and to history. I mean, the whole point of the blades, the reason why I went through hell building those blades is to have them work. So I can't be over here wussying out of using the thing I built. Said put shoes on though. Yeah, for real though, I'll tell you, when my Mark III reactor exploded, I was barefoot, and a piece of molten plastic landed under my foot and burned into it. So I'll put my boots on. Now, if it does explode, just remember, guys, very low pressure explosion. It'll be loud, but it won't be anything damaging. If it does. It shouldn't, but it might. I'm kind of scared. Do I have earmuffs? I don't have earmuffs. It's not going to be that loud, though, but... We'll turn the blades to a very low speed. Should I put them on forward or reverse? We're gonna turn the blades on low speed. You guys are gonna tell me forward or reverse. Then turn on one magnetron and see what happens. Okay? Put my shoes on too. Set reverse. Reverse. Everybody's saying reverse. 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 All right, let me go with my boots on. Let's do it. I gotta use the thing I built, right? This is like me being scared of my own balls. Can't happen. Oh, I need to get my charger quickly for TikTok. TikTok is about to... The TikTok live stream is about to... My phone's about to die. Hold up, hold up. This is not stalling. This is a serious situation. Imagine I turned it on, right? And then the TikTok live stream immediately, like, instantly went out because the phone died as soon as I turned it on. You guys on Instagram, or I mean on TikTok, would have thought that I would have been done. What? I thought this was a oh, lightning. It's lightning. 1 second. It's a lightning port. All right, we good. It's charging now. All right, let's do it. For the record, I am about to turn this machine on while the blades are spinning for the first time. One magnetron on. So we'll see what happens. But we always pray. We always cross our fingers that nothing bad happens as we do these things. Oh yeah, and I got my boots on too. So we'll see. It's on, and the blades are spinning. I think you can hear the blades. So far, so good. Hey, man, it's always a clinching moment, man. I tell you, it's scary. Like, I can't go on YouTube and be like, how to make sure your reactor won't explode. This hasn't been done before in the backyard. I'm the one figuring that. I'm the one making the guide. Oh, we got a leak. It's my quick connect fitting. Why is the quick connect fitting leaking? What type of trash fitting is this? It's a small leak, but it's leaking. I see it. Absolute bollocks of a connecting. I can actually fix that right. I can repair it with the machine. I'm gonna obviously turn it off, but I can repair it right now. I just put a cap on it. What a joke! How is that fitting leaking? What an absolute joke of a bloody fitting. How's it gonna leak? Absolute bollocks, mate, honestly. I mean, it's been leaking the whole time. But since we spin the blades, it's under more pressure, which is gonna make it leak even more. And now it's visible. Absolute bollocks, honestly. Honestly, can suck my nuts with that fitting. Now I wonder if all these quick connect fittings I have are leaking too. Yeah, I'm just gonna take it off and replace it with this plug. So that way it's airtight, you know, there's no way nothing's gonna get through this plug. That port that's leaking there was actually well, I have my pressure relief valve there, but that's actually gonna be where I put one of my thermometers, in that port. Just covering these threads with the tape. And we're gonna go ahead and screw this in. All right. There's all these damn hoses everywhere. God damn. All right, guys, listen. I replaced the quick connect with a plug, and I moved my my pressure relief valve over. So we still have the pressure relief valve in there, obviously for safety. But for anybody that does pneumatics, what causes? I've never had one of those fail on me. This one is brand new too. I just got it the other day. Now I got it from Amazon Basics, so that probably is why. It's probably just the cheapest thing possible. But I mean, it has 6 bearings and it feels high quality, but it legit was leaking around the ring, like not even around the threads. Like I've never had one of these fail, so I don't know what that was, but that was absolute bollocks. What possibly causes that, right? Obviously I'm not gonna get any more from Amazon Basics now. But here's the funny thing. I actually have some super high quality versions of these. That are like they're like the name brand. These here, I probably could have just replaced it with this here, and it would have been fine. Because I've never had them leak before, to be honest. So it just was like really? Facebook had gone out completely there. It may have just been that was a faulty one. Because I've never had it happen before. Alright, well, you know what, guys? You know what we'll do? Since we fixed that, and we know that's good, let's do it again. Let's turn on the blades and turn the magnetron back on. Facebook got completely kicked off for some reason. I gotta go live again on Facebook. Actually, I think we'll just leave Facebook at that, how it is. And we'll just stick to YouTube, Instagram, and TikTok. That's enough. 3 is enough, trust me. But let's just do it again. Let's go ahead. I mean, it was looking like we got some good pressure coming from turning on the blade with the magnetron. We did 1 magnetron. I'm not going to do 2 yet because we had the small leak. We're going to just do 1 again and let it run for a little bit and make sure nothing happens from just one. And then we'll move up to 2. Just slowly build up. That's the safest way to do these things, you know? It's cool. Yeah, it must be pretty cool watching the little trial and error stuff, right? Because that is what I do off camera. But it's like, why not live stream it, right? It's cool. Alright, so now I know. Don't get any more fittings from Amazon. Not from Amazon Basics. Not from the brand Amazon. Okay? That's the issue. I thought I could trust it. It was a great deal, though, for the amount that were in there. And the other ones are not failing, but they could fail at any moment. That's what that's telling me, so I don't like that idea at all. Alright, let's go ahead and turn this back on. Oh, great. I gotta turn the blades up because the motor's getting stuck. Hey, I will say, it is really nice to be able to stand back and press a button to get... Are the blades stuck again? What? So the thing about these motors is their speed is directly tied to how much power is put into it. So in order for them to be at a high torque, it has to be at a higher speed. But the higher the speed, the more pressure. I'm trying to do low pressure because we're testing it. But it seems like every time I turn the magnetron on, the blade is spinning fine until I turn the magnetron on. Then the blade like freezes up. So maybe the plastic is melting and it's getting too much torque, but the blades just froze up again. I think there's some type of interference with the microwaves, because I turn on the microwaves, right? And the blade stopped turning. But when I turn the microwaves back off, the blade starts spinning again. That doesn't make any sense. Unless there's some type of electrical interference. I think that's what's going on here. Because I got the blades on right now, but the microwaves are off. So the blades are spinning. I can hear them. Yeah, some type of magnetic field thing. Maybe with the transformer. The microwaves themselves are not leaking, but the transformer is outside. And it does make a big electromagnetic field. That's annoying. Yeah, that is the weirdest thing. The blades spin completely fine. But as soon as I turn them on, they just stop. So maybe what I should do, maybe what I'm going to do is I'm going to put them in forward and see what happens. They're spinning in reverse. I don't know. That's weird. I don't remember this happening before. But yeah, it's like the blades lose power completely. Thank you for the donation, Cadillac, on TikTok. I need to shield the motor. Yeah, probably. Probably. See, there's all these little problems. It's problem solving. Thank you, Rachel, on TikTok. I appreciate you. However, no, the motor's fine. The motor's not even operating at a quarter of its power. It has the power to spin the blades. It's being interfered with. Thank you, Cadillac, again on TikTok. So what's happening is reverse moves slower. It doesn't move slower, but forward does have more power. The blades are spinning, just so you know. They're spinning, but they just have problems when I turn on the magnetron that makes the microwave. So I think the microwaves are interfering with the motors, windings. Something weird is going on. I don't know what. You said reverse has much more load? We're going to put it in forward. It needs to be forward anyway for this to work properly. We're going to go forward, and we're going to see if that happens then. Once again, I'm going as slow as I can with the blades, so nothing crazy happens, in the hopes nothing crazy happens. No, it's doing the same thing. I have to shield the motor. Clearly, I'm gonna have to electrically shield the motor from the EMF because it's still doing the same thing, even when it's in forward. And the only solution may be to turn up the power really high, but I don't want the blade spinning that quick anyway. I want the blade spinning really slow. Would mount to the next one further down and allow for better spread? Absolutely, but I'm just kind of going down the line. But I might mount it further down. Because like I said, it spins the blades 100% fine until I turn the magnetrons on. And it's happening too quick for it to be like, oh, the plastic is melting and it's making too much torque. No, it's clearly an electrical interference thing. So I need to either shield the transformers, or I need to shield the motor. I need to shield, there's some type of electromagnetic field messing with stuff. It's annoying. Because we're just trying to do a genuine test. I have a mechanical shaft seal. You said separate the source of power? Yeah. The source of power is really close. I can actually do that now. I can do that now. Let me see. Let me see if I can... Let me turn this fan off. I wonder if I can do it from here. Yeah. So nothing's on now. I'm going to move the source of power further away from the motor. Okay, that took a second to do, but what I did was I just basically put some extension wires on the power supply to the motor. So now the motor power supply, the controller, is far away from the microwave transformers. So now hopefully we won't have the interference problem. But we'll see. We'll see right now. That solved the problem. Whoever suggested that, to move the power supply further, thank you. Or for whoever, because there were a lot of people that probably suggested that. But it worked. The blades are still spinning, and we have the magnetron on right now. So it was literally just an electrical interference with the power supply, not the motor itself. Yep, the blades are still on. So we did it. We solved it. So now we got the blade spinning with power going in. And let's see if let's see how the vapors are looking now. It's not exploding, so that's good. Oh yeah, I do need to put on eye protection, that's true. I just be putting on this mask, but but I want to see how these vapors look now that we got the blade spinning, because with agitation, the vapors are going to be more, right? We still don't really have many vapors. I mean, now, the machine did cool down a lot, all things considered. It has cooled down a lot since I did all that nonsense I had to do. I don't see vapors, I smell vapors though. It does smell like a barbecue. Should I turn on two? Should I turn on two magnetrons with the blades? That's the question now. Because in the past, that has been the point of explosion. But if we turn on two, we will get, it has to make more vapors because it's more power, right? Yeah, I don't even see vapors coming off of it. But I know they're there, they have to be there. You said you have to at some point? Yeah, at some point I have to turn on 12. Oh, Lord, I'm not even ready for that. Turning on 12 at once, you got me messed up. Said no balls if you don't. He said the current reactor gives crazy steampunk vibes. Yeah, definitely with all the stainless steel pipes. He said, you came here for fireworks? Oh my goodness. Come on, Ed. 2. So we should do it. Should do 2. Well, it seems like turning the blades on first, then turning the magnetrons on is a lot safer than turning the blades on while the magnetrons are already on. So we're going to turn on 2, but we're gonna turn the magnetrons on after the blades are already spinning. Okay? That's what we're gonna do. But let me see if they, like, I smell vapors coming off of this. They're not. Okay, I'm gonna go ahead and close this one. Well, not close it, but oh yeah, this smells like a gas station. There's definitely vapors coming off of this thing, but they're not flammable right now. But I'm gonna send this to the yoga ball so it doesn't suck in air if something happens, and literally make a bomb. All right, we're about to do it. 2. And the blades are still spinning at the same speed. So 2 on at once. Let's do it. I got my eye protection this time. I'm playing with y'all. What? That's 2. Wait a minute. I see something weird. I see under the lid here. You guys can kind of see it. Look. There's. I thought I heard something. I thought I heard it like explode. About to explode. There's a drip. There's a drip of oil. There's an oil spill. Where did this come from? Oh. This is. There are liquids seeping through the gasket under here. How is that possible? If this thing is airtight and vacuum tight, how are we having liquids seeping through the gasket? Oh, it's just condensation. Never mind. That's still weird though. Why is there condensation? It's water. This is water here. But I'm looking at it and it's not coming from the gasket. It's forming on this. That is so weird. It's condensation. Or maybe it is. I'm going to tighten this. Maybe it is coming from the gasket. I thought it was oil, but it's just water. That's interesting. But we have two magnetrons on, we have the blades spinning, no explosions. So clearly, preemptively turning the blades on is the way to do it. I don't know what's going on with that. Vacuum test, pressure test, does not leak, but yet we have water that is this water or oil? Wait, I'm gonna smell it. Wait a minute. Is this oil? I literally cannot tell. I cannot tell if this is water or oil. It's like, it's obviously a liquid, duh. But it's gonna smell like the reactor. So, smell is not a good way to know. Maybe I could try to burn some of it, right? Maybe this is oil. Let's see. I'm gonna put it on something. I'm gonna I have this little stick here. I'm gonna put it on this stick, and we're gonna see it. We're gonna see if it burns at all. Oh, it must be oil because it's seeping through my glove. It must be oil. Well, if it is indeed oil, then no matter how you put it, this thing is not sealed. If it's water, it could be some type of condensation. But if it's oil, without a doubt, this thing is not sealed under here. It's just weird how it's forming. It's like droplets under there. That's why I thought it was condensation. Because it looks like when you have a water bottle left out. But we got some on here. Let's set it on fire and let's see if it's oil, right? If it's oil, it should catch on fire pretty easily. You know, I would think. Yeah, maybe it's not. It's not really catching on fire. No, that's not oil. That's water, because when I did that, it just all evaporated away. So, who knows? Maybe it is condensation of some weird... I mean, now look, it could be condensation, because let me tell you why. This is hotter than this. And condensation is a difference in temperature, right? So, this is cool, this is hot. That could be why. Because it doesn't make sense to me. But why does it smell like... I don't know. Let's figure this out. Okay, we got some vapors. We got vapors here. Now here's the thing, guys. We need to remember. I need you to remember that the blades are going in reverse. You guys are saying taste it. I gotta do a taste test. I'm sorry, I ain't doing no taste test. Y'all see, I ain't doing no taste test now. Hey, thank you, Richard, for keeping the Cash App pinned in the chat. Hey, oh, we got a Cash App. I gotta thank the Cash App. It was when I was pressure testing it, so I was focused. We gotta put the blades in forward, okay? We gotta put the blades forward to truly know what's up with that. Keep it real. Truly know if it's gonna blow up or not, and it's not. They're reversed right now. Thank you, Monya Gonsalves, for the $10 on Cash App. We got some more too. Thank you, Cosmic Kitty, on Cash App for the $2 donation. Thank you, Martin, for the $5 donation on Cash App. Thank you, Mr. Smith, for the $10 donation on Cash App. I appreciate you guys. You said a light tongue on the dab is the only way for a mechanic to know what liquid it is. Sometimes, right? So, we have 2 on. There are vapors coming off. I see a lot of vapors, actually. But we got to put the blades in forward, guys. Thank you, Zai myself. Tonzo, thank you for the $2 on Cash App. You're a moderator, right, Tonzo? You can pin that message, I think. Can I pin it? Thank you very much, Tonzo, for the $2 on the Cash App. I appreciate you so much. So, you guys can't see. They're damn near invisible, but there are vapors. There are vapors that are coming off of this valve here, this output port, which would go to the yoga ball, but right now I don't have it hooked up on purpose. So that way, oh, your mods can't pin messages? Oh, okay. Well, I can't either on mobile. Let me see if these vapors are flammable that are coming off of this. They might be by now. They should be. But... no. Okay. Well, guys, we got one more test to do. One more safety test. I got to run the blades forward and run the magnetrons. I'm scared, but I got to do it. They're not supposed to run reverse. They're supposed to run forward anyway. So we're going to do the same thing. Start with 1, and then we're going to get to 2. Okay? And then if we successfully can run the magnetrons with 2 blades on in forward, run 2 magnetrons with the blades on in forward, then we'll be set, and what we'll do is we'll know tomorrow that we're good. Okay? Because I'm going to have to go after that, after we do this little pressure test here. But I need to close that damn thing. Not supposed to be breathing in this crap. Noah Armor, thank you for the $1 on the Cash App. Alright, let's do it. Oh, you guys know what's funny? You want to know something funny? The blades were already in forward. Ha! That's funny. And we're already forward. So we already passed the test. You guys think reverse will be any different? You think I should do it in reverse? No way it's going to be any different, right? You think I should? I feel like forward does more. Well, they were already forward. I thought I put them in reverse. Reverse could be bad. Here's the thing. Here's the thing, right? They are designed to only go forward. You said, I remember you changed to forward before. Well, the whole point is they always run forward. That's how we make this mission continuous. So the fact that we did it forward and they're fine, that's good. We did the test. So I don't know what was going on. Maybe the plastic we put in there has all broken down. I'm going to really have to open up this thing and figure out tomorrow when it cools down. Yeah, I don't know what's going on. We still barely got vapors or fuels that came out today. So there's still some trial and error we have to do on that one. Let's turn this fan off. But we know the best way to know is diagnostics. Opening this thing up, sucking out all the flammable vapor that's in there. Close this valve, first of all. Sucking all the stuff out, right? And then opening it up and seeing what it looks like in there. Because maybe the plastic all broke down, or maybe the plastic got in the zone where there's no microwaves from the blade spinning. you never know like what could be causing that until you open it up and see. So I can't do that until tomorrow because it needs to cool down, or else when I open it, if there is still plastic, the plastic will be burning and there's going to be burnt plastic going in the air. We don't want that happening because it'll react with oxygen, which defeats the whole point of all that we do. So I gotta wait for this to cool down. I'll do that tomorrow. You know, we'll be live again tomorrow, test running it again. But the good thing is, we did the pressure test. You said, does it smell like chemicals? Honestly, it kind of smells like a barbecue. It's weird. But, look, I know I'm not supposed to breathe it in, no matter what it smells like. So I have this mask. And we have to go to the yoga balls. But, you know, the only reason we didn't have to go to the yoga balls now was for safety reasons. Anywho, we're going to do the diagnostics, figure out what was happening. But, hey, if one thing proved to work today, were the keys. That thing keyless, baby. That thing wireless. Because these things came in clutch all day. Never had to get close to that stuff at all. Because imagine you're close to it. You let your head turning it on, and it blows up right over you. I can be away now. You know, look at this. Boom. Turn that crap off. Boom. Just like that. So something worked. That was it. But we'll do that tomorrow. Hopefully, look guys, all we gotta do is get the vapors to come out like they're supposed to. And even though these are low power runs, we'll still get some liquids, some oil. Very little amount, maybe a drop or two until it gets hot enough. Right? But we'll get something, and that's the whole point. We want to get, but we, you know, at the same time, we might have to go ahead and get 3 magnetrons on there. We might have to. We've been doing 2. Obviously, 1 was too little. 2 might be too little. I mean, 2 definitely is. Look at the size of this damn thing. 2 was too little for Mark 4. Mark 4.5 is 3 times the size of Mark 4. So just simple equations, do the maths, do the algebra, then obviously we need more power before we're going to get real results. Connie, thank you for the $50 donation on Cash App. Connie, I appreciate you so much for the $50 to the project and to history. Much love and blessings your way, Connie. Yeah, I just got it. I see you there, Connie. Yes, I like dinosaurs on Instagram. Hey, much love to you. Much love. Yes, I like dinosaurs. Or Connie. Blessings to you for sure. I very much appreciate that contribution to this project. So, good thing, guys. These work. We got the blades to work, reverse and forward, while the machine is running. No explosions. We're making big progress. Now is a matter of, we're going to run it again tomorrow and see if we can get any actual oils. I'm going to put more plastic in, blah, blah, blah. If nothing happens then, at that point, now we know, okay, now we need to build the next magnetron mount. We have to get more power in, which obviously we have to do either way, but we're just kind of like building up to that point. Because testing 2 magnetrons is different than testing 3. Testing 3 is different than testing 4. It's not just 1 plus 1. When you add another magnetron, it's like 1 times 10. You know what I'm saying? Like you add a lot more. It's exponential, all right? So it gets more and more dangerous. So I like doing these little small tests, slowly building up. So thank you all for stopping by. How long was the live stream out? We've been live for 2 hours, 30 minutes. I see. 2 hours, 40 minutes, pretty much. Long live stream. Glad to have you as a part of it. Thank you all for the donations and for stopping by. I'll see you guys. We'll be doing a Q&A tonight, so you guys peace out. We'll be doing some more test runs tomorrow. Much love. Damn, dropped my phone. It's like I'm gonna drop my balls down your mouth. Alright guys, on YouTube, I'll see you guys tomorrow. We'll be live again. Thank you for stopping by. Long live stream. You guys take care.